Hello viewers, this is Amarendra Reddy, faculty from Electrical and Electronics Engineering Department, and again we are going to discuss here with control system and some basic questions. So here this time we are going with some basic questions on trans function, impulse response, and how to find the response, or if you know response, how to find the trans function, or some basic concept related questions here we are discussing. So now let us have a look. Means really these questions are in the same standard as I mentioned even earlier videos also. So here also we are taking such questions only, useful for our exam. So please watch this video and get the revision for these topics. Okay, right? We will see one by one question. Okay, look into that. First question, if you see here, the trans function of a system is given as what 1 by s plus 1 into s plus 2. Then what is its impulse response? We already have. Okay, impulse is a kind of input. Okay, right? Impulse is defined for what only just particular time instant here. So this is what impulse is defined for only short time interval. Okay. So where delta t tends to what 0, and generally we indicate impulse with what delta of t, right. So impulse is indicated with what delta of t mathematically when you show like this. Okay. So how you are going to have the what its Laplace transform? Because mathematically if you take, we indicate with some magnitude like a, okay, but it is defined only when time t is equal to what 0, and 0 when time t is not equal to what 0. This is the way we write the what impulse signal mathematically. Now what is the Laplace transform of this impulse? Whatever a kind of magnitude we have, Laplace transform of impulse is what 1. By that, if you already have a trans function for the system, because when you are giving impulse as the input, what is the Laplace transform of impulse, which is already what 1. So you already have a trans function ratio of output to the what input u of s is equal to given as what 1 by s plus 1 into s plus 2, right. U of s is how much here? U of t is what impulse is given, and u of s becomes what 1 only. Then what is y of s? Y of s becomes its impulse response, that is 1 by s plus 1 into s plus 2. But we want the relation in what time domain. So for that we need to find the what Laplace transform. So impulse response for the system is nothing but, which is nothing but y of t, which is nothing but what L inverse of y of s. If you find the inverse Laplace transform, so how we get the inverse Laplace transform for this? Here I am going with this L inverse of, I am writing that into the partial fractions like a by s plus 1 plus b by s plus 2. Then if you are able to find the values of a and b, okay, what are the values of a and b? So substitute s is equal to minus 1 in the remaining term, s is equal to minus 1. If you substitute here 1 by minus 1 plus 2 means 1 only, right. So 1 by s plus 1 we will get, and s is equal to minus 2 you substitute in that remaining portion. Okay, by residue theorem we are going with finding the partial fractions. S is equal to minus 2, if you substitute here minus 2 plus 1 means minus 1. So minus 1 by s plus 2 we will get. Now if you apply the inverse Laplace transform here, what will be the impulse response here? What we get? Impulse response is equal to 1 by s plus 1 means what is its impulse response? Inverse Laplace transform e power minus t, e power minus t minus e power minus 2t we will get. This is the what impulse response. Means directly if you find the inverse Laplace transform of your trans function, that will give the what? Its impulse response. So, this will be the what? Matching option for our result. Okay. Now, move on to the next question here. Okay. What is the Laplace transform of t e power at? Okay. Sometimes they give even questions on basic standard transform pair. E power plus or minus at is how much here? What is its Laplace transform? 1 by, if plus is there, we will get what? Minus here. If minus is there, we will get what? Plus. So, 1 by s minus or plus a. If t is there, what we write means we write it as what? 1 by s square. Now, we need to combine both. What is the question here? T e power at only. T e power at means what will be the result here? 1 by t means s square, but e power at means s place what we get? S minus a whole square we get. 1 by s minus a whole square must be the what? Relative option for the given function. Okay, this must be the what? Right one according to the what? Function given. Okay. So, sometime question we get because it is a basic question and Laplace transform tool is compulsory when you go with control system or even some application of our electric circuits. So, sometimes we can have a question like this. Okay. Move on to the next one here. Again here also one more question related to Laplace transform of the function shown. Okay. This time it is having what? Some time delay, or what we call this, it is starting after lag of tau is equal to 1 second. Look at this, f of t Laplace transform is how much here? F of s. Okay. F of t Laplace transform is f of s. What is f of t minus tau? Tau means it is a transportation lag. Got the point? We call that as transportation lag, or we call that as what? Time delay. Okay, it is starting after some time tau. Then what will be the its Laplace transform? E power minus s tau into f of s, like that we need to take. And first of all, what kind of function it is? It is a ramp function. Okay, simply if it is starting from here, we take it as what? Magnitude is given. Okay, 4. Okay, 4 is given. So, what is its Laplace transform? 4 by s square we write, but it is starting after what? Some lag, like some time tau. Okay, this is what? Tau. What will be the impact here? So, this will be the what? Given function, right or not? So, some time delay is there. So, e power minus s tau. Tau is how much here indicated? 1. So, e power minus s into 1 we will take. Means what will be the result we get? 4 by s square into e power minus s only. This must be the our right option here. So, which one is matching with that? 4 by s square into e power minus s. This is what matching with our result. Okay. So, Laplace transform properties and basic transform pairs is also important for our exam, right? Easily you can crack if you are good at these kind of basics. Now, next question, if you see here, what we have in this open loop trans function with the unity feedback is given by what? Okay, this one is what? Open loop transfer function, and the feedback is what? Unity feedback. Look at this. The poles of the closed loop system. Here the question is what? Asking for the poles of the what? Closed loop system. Okay, right? So, don't be in a hurry and directly select 0 and minus 2, which is waiting for you in a first option. Those 0 and minus 2 are the poles for open loop. Closed loop means you have to find closed loop trans function. What is that? Closed loop trans function, which is equal to open loop trans function by 1 plus open loop trans function when we have what? Unity feedback, that is negative unity feedback. We have that relation. So, from here you can find 1 by s into s plus 2 by what? 1 plus 1 by s into s plus 2. Simplify further, we get 1 by s square plus 2s plus 1. So, now this is the what closed loop trans function, and the denominator of the closed loop trans function gives what? Characteristic equation. So, what is the characteristic equation now? S square plus 2s plus 1 is equal to 0. This is what characteristic equation, that is the denominator of the closed loop trans function. So, now if you find the roots, okay, means you can write it as what? S plus 1 into s plus 1. From these roots only we get the what? Closed loop poles. So, here if you recognize, what are the closed loop poles here? Minus 1 comma minus 1. So, which is there in our option? This must be the correct one. So, do not be in a hurry, check the statement clearly, poles of the closed loop. If they ask poles of the open loop, means you can select 0 and minus 2, but question is to find the what? Poles of the what? Closed loop system. So, if you go with that, minus 1 comma minus 1 is the what? Right option for the what? Given question. Understood? So, you read the question carefully, even though you know the concept, we may do the what? Mistake, but when you identify that in a first option, we will be in a hurry, right, in writing the what? Exam. So, definitely we will lose the what? Score when you do like that. So, do not be in a hurry. So, you please maintain patience while writing the exam, maintain that silence and go with calm and pleasure and write the what? Exam. So, automatically we get the what? Success. Now, move on to the what? Next question here. What we have here? In unit impulse response input, okay, or unit impulse input only, is given to linear network, has a response of what? R of t. What he is saying? R of t is a what? Unit impulse response. Okay, this one is what? Impulse response, right? And unit step input to the system is giving what? R of t is what he is calling impulse response, and S of t is calling it as what? Step response, right? Then what will be the relation among this? What? The response R of t means impulse response, how we get? Look at here. If you recognize the what? Impulse signal, okay, right? Impulse is defined at what? Short time interval, just before we had seen in one example, right? Got the point? If you just integrate the what? Impulse signal, okay, constant, and if you just define, okay, right? If you integrate the what? Impulse signal, okay, what we get? What we get? We get what? Constant means we get what? Step signal. If constant A is there, we get here A. This is what? Step signal, right? So, R of t, U of t, whatever you can call here, just generally indicate all the inputs here. Got the point? Now, if you integrate the what? Step signal, what we get? We get the what? Ramp signal with a slope of what? So, this I am indicating input is like this. And if you integrate the what? We get the what? Parabolic response like this, right? A by 2 t square. Got the point? And this is what? AT. Now, if you just find the what? Reverse manner, you know the parabolic and how to get the what? Ramp, you just need to do the what? Differentiation for that. If you know the ramp signal, how to get step, you need to what? Differentiate that. Look at these arrow marks, how we are doing. If you know the step, if you differentiate the step response, we get the what? Okay, we get the what? Now observe this. It is what? D by dt. Okay. So, what is that representation here? D by dt. Got the point? So, if you go from left to right, we need to do the what integration. If you want from right to left, differentiation we need to have. Impulse response, if you want, okay, from the step response, what you need to do? You know step response, what is indicating? Is saying that it is S of t, and this one is what? R of t. How to achieve R of t from here? R of t, which is equal to, how to get R of t from step response? D by dt of S of t, right? Differentiation of step will give this what result. In that way you can observe this what relation, okay, right? These are the what generally standard test signals we use in our control system, right? Step, ramp, parabolic inputs are generally be used in what time response analysis, and impulse signal is used in what stability analysis. Okay, understood. This is also useful for our exam point of view or even analysis point of view, right? Understood? So when they give R of t is the impulse response, S of t is the what step response, then how to relate impulse and step response means impulse response is the what differentiation of the step response. Okay. Now move on to the what next question here. What is saying here? Right? So here unity feedback system has the following unit impulse response. Okay, look at this. Unit impulse response is there. Then what is its open loop trans function is there. Okay, unity feedback means we already know that. Okay, Laplace transform of impulse response is nothing but what? It's a trans function only. But with the feedback is saying, so if you find Laplace transform of how much here? Minus t e power minus t plus 2 e power minus t, we will get what? Closed loop trans function, right? After that he is asking to find the what open loop. First you find what is closed loop. E power minus t means what we get? Minus 1 by s plus 1, t means square will get, so minus sign means minus, okay, plus e power at means what we will get? 2 by e power at means e power minus at means 1 by s plus a means 1 by s plus 1 we will get. This is what our closed loop trans function. If you simplify here, take LCM, what we will get? What will be the closed loop trans function? If you take LCM here, what will be the result? S plus 1 whole square I can take, and this one is what? The minus 1 plus 2 into s plus 1 we will get. Simplify further, 2s plus 2 minus 1 by s plus 1 whole square. Simplify now, this will be what? 2s plus 1 by s plus 1 whole square, but this is not open loop, this is what? Closed loop trans function. So after having closed loop, we already have a relation among the what? Open loop and closed loop. What is that? Look at here. When you know closed loop trans function, how to find open loop? Closed loop trans function by 1 minus closed loop trans function. Use this relation here, then what we get? 2s plus 1 by s plus 1 whole square by 1 minus 2s plus 1 by s plus 1 whole square. If you take LCM, what will be the result? 2s plus 1. Okay, what will be the result here? 2s plus 1 by denominator, if you see, s plus 1 whole square is how much here? S square plus 2s plus 1 minus of 2s plus 1 means 2s plus 1 will get cancelled. What will be the leftover term? We get only s square. So 2s plus 1 by s square means where we find that this one will be our result. Okay, understood? This is the way we need to identify the what result. Okay, observe the question carefully, whether they are asking the what open loop trans function or closed loop trans function. Okay, so with unity feedback impulse response is given. If you apply the Laplace transform, we get the what closed loop trans function. from the closed loop trans function we are identifying the what open loop trans function in this fashion. Okay. Move on to the next question here. Read the question properly. An open loop system is converted into a closed loop system using negative feedback. The feedback path has a unity gain as compared to the open loop. The closed loop, okay, the closed loop system has the following property. Okay, look at here. What will happen? Suppose this is what our closed loop with unity feedback I am considering, right? Unity feedback means H is what equal to 1. Then what we will get? This is what reference input R of S and this is what control output. So, what will be the result? C of S by R of S, which will be equal to Z by 1 plus Z. This is what closed loop, right or not? Closed loop control system. What is the open loop system? Open loop control system means simply we have G, okay, with no feedback. So, what will be the result? C of S by R of S is equal to, means if it is input and this one is what output, what will be the result? G only we get. Now, if you see that gain is what G in the open loop and here gain is what decreased because Z by 1 plus Z. But here what is saying overall gain is what increased, means it is wrong. Bandwidth is what increased, not reduced. Disturbance rejection capability is what increased, not decreased, means effect of parameter variation is reduced. Okay, this will be the what correct statement that we can observe from the what effect of feedback or what principles of feedback. Understood? By introducing the word feedback, what will happen? What are the points we need to note here? By introducing feedback, overall gain is what? Overall gain is what? Reduced. And bandwidth is what? Increases. Bandwidth is increased. And next one is what? Effect of parameter variation is what? Effect of parameter variation is reduced. Okay. Next, what you can observe here? Disturbance or noise rejection capability, disturbance or noise rejection capability increases, but here decreases is given. Okay. So, these are the effect of feedback on the what overall system. Understood? Okay. These are the some of the questions we took from the basics of control system point of view, means finding the response or means impulse response, step response, finding trans function, and again some open loop, closed loop trans function evaluation. What will be the effect of feedback? Such things we discussed in this video, right? Please utilize this opportunity and try to get success in this exam. Okay, right? All the best for your exam.